It feels really nice and warm.
All right. Today we're going to look at solving exponential and logarithmic equations. And we're going to solve each. And you're going to need your calculator.
I'll get mine.
I'll get mine out. Calculators. Oh. Calculators.
Yeah, you don't know how to use the calculator.
Probably second ln.
It's e to the x.
Yeah.
So if you just press it, then okay. And I think I did all of that quiz.
You take that one. All right. For this one, do you know what the answer is? 9? 2 to the 9th equals 512? But what if it was something that you didn't know? Like I could do 3 to the x equals 3 or 512. So let's talk about how do we solve logarithmic and exponential equations. This is an exponential equation. And what we can do is we can either take the natural log or the log of both sides of the equation. So let's say I'm going to do the log of 2 to the x equals the log of 512. And now, using those properties from last week, Thursday, what can we do to simplify that so we can solve for x? Bring x to the front. Remember, our powers can come to the front. So then this is x log 2 equals log of 512. And now how do you solve for x? Divide by what? Log 2. So you're going to, in your calculator, do log of 512 divided by log 2. See what you get.
So before you divide by 2, you have to move the exponent.
The exponent has to be moved first. Yes, because it's a power.
And then the natural log, that's when you do that log e, right?
Natural log is, ln is the same as log base e. This is log base 10.
So ln e is
Yes, ln is the natural log, which is equal to log base e.
so log e equals ln.
ln. Yes. Did you guys get 9?
Yeah.
Anyone need help? Got it?
Got it. This would be really helpful.
Did anybody happen to do ln on both sides? See if you get the same thing? Do you have to redo the whole problem if I ask you what happens when you take the natural log? No, all you have to do is do ln of 512 divided by ln of 2.
when you like just on part A stuff, when you do that, so you get like x equals like when you do like x equals log 256, and then could you just do
You have to divide by log 2, not just 2 divided by the whole thing. And do we have any rules that say if you take log 512 divided by log 2? Is that one of our powers, our rules?
well that's just my question, like so that's two different things.
Yes.
Okay.
Let's maybe refresh those rules. Here's our properties. We can split them up if we're taking the log of 2 of them being multiplied together. We can split them as log e, multiply log e plus log b. If it's log of u divided by b, then we can subtract them. And then here's the one we just used, the power to a power. Because it's ln, or log or whatever, of 512 divided by ln of 2, I can't do ln of half of that. I have to do ln of 512 divided by ln of 2.
What's the difference between putting in log 512 divided by log 2 doing ln?
Nothing. It's just using, this is using log base e, whereas the log is using base 10.
Okay, but when I put it into my calculator, I got like 3 point something.
You're taking the log of everything there. This log of 512 parentheses. Now divide. So what's happening is without that parentheses.
It was like acting like there was a
Other questions? Hey, what are we going to do with the second one? Anyone have this answer? Have any ideas what to do?
Would you,
You add ln x to those,
Yep, add ln x to both sides.
and divide by ln?
Well, actually, we can't divide by ln, these go together. That'd be like taking the square root of 2 and dividing by 2. But what do you know? I'm taking the natural log of 5 and it equals the natural log of some other number x.
to just put in log 5 and I'll tell you what.
So x equals 5.
X equals 5. We had the property. Where's that one at? Right here. This one right here that says if ln of x equals ln of y, then x equals y. Okay? So x equals 5. Okay, you try C. All right, what did you do on C?
What you did on A.
What did I do on A?
Put the exponent in front of log.
So I took log of 1/5. I did the log of both sides first. And now I put the power out in front. Then what'd you do?
Divide by log of 1/5.
And you should have gotten a -3. Help putting this into the calculators.
Wait, I got -3.
Oh.
It's a rough day.
All right, what about D? We need to solve for X. And E is that 2.7 blah, 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 blah number.
Did you do natural log?
Natural log, okay?
Let me just move here.
Now what?
The X up front.
Do what?
The X in front.
X in front.
You divide by L and U, and does it L and U equal 1?
Do what?
Is it L and U 1?
Yep, ln of E is 1. So this just goes, this here is 1. So X equals ln of 13.
Do you want us to second?
Nope, just leave it. If they say solve each and don't tell us to round it, we're going to leave them as exact answers.
Wait, you wouldn't divide by ln of E?
What is ln of E? It's 1, so it's 1 times x.
Oh, so you wouldn't solve for ln 13?
Nope, just leave it ln 13, please.
Okay.
Because we know ln 13 is not going to give us something exact. And we know that just by looking at the problem.
I have a question.
Yes, ma'am.
On your calculator, at the bottom, what does it mean when it does like the, it says like rad?
There's a radians. It's in radians mode. No, radians is, the radians is, pi. Actually, that's the next thing. All right. E. What do you think about this one? ln of x equals -8. And log of x equals -2. This should be you should know how to do this. And if you don't, can't you apply the definition of logs and natural logs? The definition of log?
I just slept since then. Many times.
Remember our definition, the log base A of B equals C. How do I write that? Without the logs.
A log, oh. A ln?
B equals what? A to the C power. This is the base, logs, so it's the base of our exponents. C is our exponent, E is what it is. So in this case, ln has a base of what? So what's this base here? E. So it's E raised to the negative 8 equals x.
So would you not solve that one either?
Nope, that'll be decimals too. I want that one exact. I'm going to get to somewhere we are going to.
How do you know that A is E?
Because it's, the question is, how do I know A is E? How do I know that this has a base E right here?
Because ln does. Is that kind of like log stuff?
Because the log
I don't know the
base E of x is the same as the natural log of x.
answer. Okay.
So what about f? You probably will never need it, but
We need it for the test.
you need it for the test. It just depends where you go. And I'll get to that story sometime. What's the base here?
0.
X.
10. Remember log base 10 of x. So that's 10 raised to what power? Equals what?
X.
And now what is 10 to the negative 2?
1 over 100.
1 over 100.
Is that just me?
Sample 2. Solve each and round to 3 decimal places. E raised to the negative x squared equals E raised to the 5x plus 6.
I know what it is, baby. Thank you.
So it's x plus 3 and x plus 2.
How did you get x plus 3 and x plus 2?
Say times and make 6 and add 5. Because you put x to the negative x squared on the other side and be positive, and then you factor.
So what did you do first?
I took out the e's.
Well, okay, yes, thank you. You took out the e's because why?
The same.
They're the same. E raised to this power equals E raised to something else. The powers have to be equal.
Bless you.
And now we'll add x. I'm going to add x squared over. And factored instead of equal to c. What about b? 4 times 3 to the x equals 64.
first. Divide each side by
Divide each side by 4. We want to get that base by itself.
4.
So 3 to the x equals 16. Do you know any number raised to 3 raised to some number that equals 16? No, so this is where we get to plug it into our calculators because I want it to 3 decimal places. So what do you do first?
Would you do log of 3, log of 16?
Log of 3x equals log of 16. And now it's just like those previous problems. Bring the x in front. Divide by log 3. Check and see if you get the same answer I do. You will not get that. Let's try this one. E raised to the 2x minus 7 e to the x plus 12 equals 0. We need to isolate somehow those exponents. Is there any way to do that?
So subtract 12.
Okay. Then what will we do after subtract 12?
Put the 7 in front of the x.
Put the 7 where?
In front of the x. Instead of putting the exponent in front of the e, you put it back. Or would you do the opposite?
Okay, let me ask you something. If I had 2 to the 4th, and I had 3 times 2 to the 4th, is this the same as 2 raised to the 12th? Well, what's 2 to the 4th? 16. 3 times 16 is 48. And we know this is going to be way bigger. That rule you're looking at is only if it's logs. Only if it's log can you do that. Okay? Those don't work.
2 to the 12 is 4,096.
There you go. So way apart. Okay, so that doesn't work. Any other ideas?
Is there any way you can get like the e's for like, because wouldn't one be positive and one be negative? So like, is there any way like you could separate it so then you can set the exponents equal?
Nope.
You divide by 7.
Then I'm going to have, if I divide by 7, I'm going to have 7 here,
Um,
7 here, and 7 here. So that's a mess. Okay? Well, let's see. What if I wrote it like this?
Or like change the sign?
Where did that get me?
You now have 2 e to the x.
I have just e to the x's. So what can I do now?
Subtract 70x from EX.
No, because this is ex squared. Let's look at this. What if we let y equal e to the x? So when I put a y in for e to the x, that's y squared minus 7y plus 12 equals 0. And that'll factor. So this factors to what? Y minus 3, y minus 4. Except now what is y? It's e to the x. So this would factor to e to the x minus 3 times e to the x minus 4. Does that multiply out? What's e to the x times e to the x? E to the x squared. The quantity e to the x raised squared. And then negative 3 times negative 4 gives us our 12. There's negative 3 e to the x, negative 4 e to the x, which gives us that. So we kind of used what's called substitution. And now, what do? Set them each equal to 0. So I have e to the x equals 3 and e to the x equals 4. I need to know what x equals. So what do? Natural log both sides, so ln of e to the x equals ln of 3. Here, ln of e to the x equals ln of 4. So x equals ln of 3 and x equals ln of 4. Because when I bring the x out in front, we're left with x times ln of e, and what's ln of e? 1. And now you put it in your calculator because I want 3 decimal places. Make sure I did it right. You guys agree? Or not?
For 3, I got what you got for 4. Makes any sense.
Oh, you're probably right. Better? Anyone not done? We have one more example. Another one, solve each. How many know how to do this one? Can I apply this definition again? This is a base E, so E to the 2/3 equals X. Am I gonna put that into my calculator and give you a decimal answer? It says solve each. It didn't say round, so we're gonna leave it. I would expect you guys to know how to do this.
Since the log 4 is the same, you just take it.
Log base 4 of something equals log base 4 of something else. So the something and something else are equal. Take about 30 seconds to 60 seconds and talk to your neighbor about what you think you ought to do to solve this problem. He's not talking nearly as much as my fifth grade
I
students.
put log 33x up to the other side. I don't know if that's right, but I just I like things being equal to 0, and that's not what we're supposed to do.
Yeah.
Since all the logs,
What happens when you have a negative log though? You could probably move the
Yeah.
6 over so it's positive. But I
Okay,
just think since they're always 3,
I'm
that there
hearing-
shouldn't be anything.
that you guys are telling me that log base, that we can
that's
solve
what you
this
did on
by 5x plus 13 minus log 3 of 6 equals log 3 of 3x. That's what I did on which one? I did on B because I just had a log equals a log. But I have a minus sign in there now. So what can I do and to write the left side for
Find it.
1 log.
Yeah.
Do
it's
what?
The first one divided by the second one.
Yep, this can be log base 3 of 5x plus 13 over 6 equals log base 3 of 3x. Apply those properties. Now can we ignore the logs?
Yes.
Because it's log base 3 of 5x plus 13 over 6 equals log base 3 of 3x. So 5x plus 13 divided by 6 has to equal 3x. You should get 1.
Oh, that's fine.
Only time you can set semi-zero is when 1 log equals another log and the bases are the same.
Can you go through that because I'm not getting one?
Which one? The one I just did?
Yeah. Like on how you got 1.
Oh, okay. Cross multiply. So
Okay.
that's
Never mind.
18x equals 5x plus 13. You with me?
Yeah.
And then I subtracted 5x. And then divided by 13.
Yeah, I just wrote it down.
What about D? What should we do first on D? We want to solve for x.
Subtract 6 from this.
Subtract 6. Then what?
Are you allowed to divide by 3 or is that?
What I would do.
Oh, that's a 3? Oh, I thought it was 31.
Can you just leave it like that then?
Do what?
Can you leave it like that?
Well, we have to solve for x.
So then would you do like on that?
This is now just like A, like example A. E to the negative 2/3 equals x. One more. Everybody done with D? E. Log of x plus log of x minus 9 equals 1. So what about this one?
Multiply them together.
Do what?
Multiply log x and 9.
So we have log of x times x minus 9 equals 1. Now what? Can I apply the definition? Yep, 10, this has base of 10. So 10 equals x squared minus 9x.
What happened to the 1?
What, 10 to the first power? It's 10 to the first. So it's now an x squared. So I have to put it equal to 0. X equals 10, and x equals negative 1. Anyone see any problems with x being 10 or x being negative 1?
Can it not be a negative?
It cannot be a negative. So why can't it be a negative?
Because it has to be greater than 1.
It has, this base here, x, has to be greater than 1. Greater than 0. Here's our very first lesson, Unit 3.1, where a is greater than 0. And when you plug them back in, well, when I put 10 in, I'm going to get 10 and 1, so that's okay. When I put in a negative 1, it's a negative x. So negative 1 does not work. The only one that works is 10. So not only do you need to look at your answers to make sure that there's no negatives when you plug them back in.